Thanks for coming. Welcome. We are going to talk about, we should have named this organizing several teams for rapid delivery. But I'm Jason. This is Micah. This is Patricia. Hope I turned the right way. Good news is we will be out of here early. We'll be out of here in about 20 minutes unless you guys have just a whole bunch of questions, and so you can be first in line for happy hour. So yeah, you bet. We're from Credera. We're a Dallas-based consultancy. We will not give you the Credera sales pitch or any of the NASCAR slides of all of our clients. If you're interested, come find us afterwards. We'd be happy to talk about it, but we want to get right to it and get you out of here. So remember that when our marketing department finds out about it and I'm looking for a job, I'll be looking to all of y'all. Okay, so microservices, they're great. But they're also difficult. They provide a lot of challenges. And I think everyone here at a conference about running microservices in Pivotal Cloud Foundry would agree with that and have probably experienced a lot of those challenges. We'd say that managing teams, developing them, is not great, right? And it's much, much harder. And that's what we want to kind of talk about today. You will get a little bonus. There's a little bit of technology in here. It's not all org structure. But we want to talk about our experience managing and running a lot of these large projects, building microservices, some of our organizational strategies, and then some of the technical things you have to really do to support those organizations, as well as some things around communication. So to do that, we thought we'd start with a case study. This is a project that we started back in the fall of 2014. It was for a healthcare company that was doing a custom analytics platform. And what they wanted was really a suite of applications. I lovingly referred to it as Google Analytics for hospitals, where they had lots of applications that would focus on different areas of the hospitals, different departments or functions, but they all kind of shared the same set of core services. Things like, how much did I spend on this? How many of these did I buy? What are my discounts? What rebates am I eligible for? Those type things. This is a lot of data from tens of thousands of hospitals, and they had a huge roadmap of features that they had already promised. Has that ever happened to anybody in here? No, I didn't think so. Must be just us. Right? So, they had promised, hey, we'll deliver this product in Q1 and this product in Q2 and this product in Q3 and so on. So we thought, well, we'll do something like this. And I think this probably looks like every other architecture diagram you've seen at this conference, but we'll have a lot of applications that use a lot of these services. We'll have some of the really, kind of key pieces for microservices, a gateway, service registry, configuration server, and that will let us build reusable services, check. We can add applications and scale them out horizontally as fast as we need to. It's really cool technology, and we can just scale out lots of people and deliver these things real fast. That was the theory, and we thought we'll use Spring. Shout out to Pivotal and Spring. It's been a great platform. As you can imagine, it's the Zool, Spring Cloud, Netflix Stack, Zool, Eureka, the configuration server. We use Spring Boot for all the services and a lot of other components for security and batch processing and data and those type things. And it worked great, right? First deadline came along. We built everything. Team about 8 to 10 people. They used all the Spring stuff, which provided a lot of plumbing, let us get right to the problem, solved it. They were very, very happy.
Yeah, so this was such a great success. We immediately started on the next app. So we added another team. Second team comes on, 8 to 10 people are working on this. Now we've got 2 teams. We did all of this work. Another 3 months goes by, they delivered, and it worked really pretty well. Both teams worked independently of each other. Not much interference, a little bit of coordination, but nothing that we can't manage. So of course, it's working so well, we decide, let's go for it. We're going to add 2 more teams immediately. This time we're going to develop 2 more apps that are running on this, and we've only got 3 months to deliver this. So we throw more people at the problem. That always works. We continue, we're scaling out. This should work. Everybody work in their own environments. Let the teams do their own things. And 2 months in, we're here, and all progress stops.
So why is that? Well, reality check, it actually looked like this. We showed our pretty architecture diagram, but as time went on, it actually looked like this. Teams were just stepping all over each other. You've added tens of people to this project, and what worked with 8, 10, 20 people just did not scale, right? Making a single change to a feature would touch multiple services. We had cascading changes. You can say, yeah, do versioning, and we tried, but it didn't really help that much. It just kind of made it multi-threaded chaos instead of single-threaded chaos. We also had problems with team health, right? You never want it where one team is staying late till 9, 10 o'clock at night, day after day after day, where other teams are leaving at 4, because how we had structured the teams, we had bottlenecks, right? We had some training issues. This was mainly because the applications that we had developed in quarter 1, quarter 2 didn't exactly look like the applications that we were having to do in quarter 3, quarter 4, so you couldn't just copy and paste that code over. We also had so many meetings. People were seriously spending 50% of their time in meetings, and how that always works is it's not the people who get to leave at 4 that are spending that time in meetings, it's the people that are staying till 10, and that's really miserable.
They're usually explaining why everyone else is waiting on them.
Yeah,
so let's have a meeting.
Yeah, meetings, they always help, right? Last but not least, we had some things outside of our control, and this is typical, this is the reality, right? We had some legacy process, we're consultants, we work with clients. We also had shared environments. That was our particular challenge, was we had the same QA environments. They were all on the same server. One box goes down, it can cause chaos on every front. You don't have a wall to back against. And we didn't have any cloud services. We were really just stuck with the hardware that we had. And that was just our reality, so what do we do about it?
So this was supposed to be faster, we thought. So we did some analysis. Discovered, it can be faster as long as you do this, as long as you align the solution that you're developing with the organization that you have. Now, if you're looking for happy hour quickly, you can leave now, because this is the most important part of the talk. This statement I want you to remember for sure: align your solution with your organization. So what does that mean exactly? So alignment, everyone here has heard Conway's Law. You probably heard it in every talk you've been to. But that's a starting point, and that's actually how we started. We had teams working independently. They own a small set of services, and any changes are easy to make. The services are easily replaceable, and the coordination costs are extremely low with a couple of teams. But as you add more teams, more sharing, that exposes those stress points in your application and your design. So where those stress points are where we have to increase the coordination between teams or between people. So every place that we added a new feature to an existing service, or where we have where we are changing a service contract because someone else needs something. Don't do that often. So our formula here, not ours exactly, but the coordination cost plus the partitionability of the work will give you how efficiently you're able to make changes in your design. So, partitionability. Has everyone read The Mythical Man Month? If you haven't, if you don't own that book, after this, go buy it immediately, read it this weekend. Lots of wisdom. So, Fred Brooks, in the book, points out that when tasks are perfectly partitionable and there's no coordination cost, adding workers will significantly decrease the time it takes to complete the work. So that's our first graph on the left. The middle graph shows that when your work is non-partitionable, adding workers does nothing. It's completely neutral. And Fred Brooks' classic example is a woman having a baby. It takes 9 months regardless of how many women are there. So the third example is we have partition tasks, but very high coordination costs. So you can see this is very surprising. It's not neutral. In fact, it's very detrimental. So in that third one, our time goes way up once you start adding more people. So how do you get better partitioning? The first place that we look is in our code base, and we discovered that as you add features, you needed to create surface area in the code for workers to be able to take tasks without stepping on each other. So to do this, we used something similar to the open-close principle. In other words, open for extension but closed for modification. So you look at the code example here. You see, that's looking at the code. That was one of those places that we always look at and said, this is a place we need to refactor the code. We've introduced a new idea, so rather than creating a big if-else, let's push this into two different file systems, or two different packages. So as your code grows, another thing that we discovered is that if your code is growing vertically, in other words, you're adding packages underneath the existing packages, you're going in the wrong direction. Your code should grow horizontally, adding new packages as you add features to existing services. Now, another place that we discovered we had issues was with cascading changes. Where we have cascading changes, these are really hard to find. We discovered that we had some semantic coupling. Now, semantic coupling is any sort of shared concept that's shared between multiple services. Now, these are really hard to find, actually. There's also a dependency on behavior. So services that do lots of things, especially side effects, those are also places where you can discover that. So let me give you a simple example that we had. So we have an app that does some finance, and it needs to calculate the savings, or the spend by customer for the last month. So our finance app pulls up our customer data, pulls up our invoice data, and does the calculation for us and does the analysis for the customer. So a significant change for our invoice structure would cause that change to ripple up through those services, everyone that's using this. So what we did is we discovered places where rather than exposing those domain elements as they existed, we changed and created aggregates out of those. So instead creating a new service that's an aggregate based on the previous two services.
Yeah, so in this case, it would be spend, right? And I think a lot of people will recognize, well, now that's a duplication of data, but these are distributed systems, and some amount of duplication is going to be, necessary and required. The real goal here is to keep a change in one place from cascading and affecting others, and then those people become the bottleneck. So I think that the third thing we had found, right, from an architectural or technical perspective was we really had to eliminate shared dependencies. Does anyone own a t-shirt or a coffee mug or anything that has dry on it, right? Do not repeat yourself. If you do, you might want to step out. You might not like this part of the talk. But some redundancy is okay. In fact, we have a principle we call Gary, which is go ahead and repeat yourself, right? If there's a lot of benefit sometimes in terms of speed to market, in terms of just repeating yourself. And an example we have is, I'm sure many of you have worked on systems where you have lots of components, services, apps, whatever, and they all seem to have this one jar that they include, and it usually has a name like something common, something, right? Anyone? Yes. And every time that thing changes, it ripples all the way through. Well, and a lot of times those changes are just simple functions, right? In this case, we're validating a set of insurance types, right? And so we have some common jar that everyone has to stay in sync with or version and keep track and update to and retest every time it changes, when in reality all you're doing is checking, right, what type is this? I would say there's a couple of sneaky things though that happen as well when you have a lot of these shared dependencies. Like what happens if different services have slightly different requirements about what is a valid type? that's where you get a lot of, like Micah showed before, the if then else in your services, which makes it very brittle, very fragile, and really increases the time. You know, I pulled this example out because someone thought they'd be real clever and use the Java 8 Stream API. Well, super, except not all services are running under Java 8, right? And so it's, again, an area where dependencies can really bog down and cause a lot of coordination. So, you know, our example from Gary, go ahead, repeat yourself, is why not have service 1 check, if it needs to know it's an HMO or a PPO, it can check it, and the service 2 needs to know if it's an HMO, it can check it, right? This is really not, you know, a bad architecture or a bad problem from a design perspective. So, you know, kind of summarize this, the design has to evolve continuously. You have to find these hotspots, bottlenecks, places where you're coupled, and you really have to break those out and refactor ruthlessly in order to make surface area for different teams to work in parallel. And in fact, for a lot of those components, many of our kind of core components and applications, we've refactored 4 or 5 times to get them really in a way that can be developed concurrently by multiple teams. That sometimes has its own challenges with management, but that's a different talk. We can find us afterwards.
Okay, so now at this point we've addressed all the design issues, and now we can actually get the teams working, right? So let's go. What we ended up doing, you hear a lot, think about like a drinking game at the conference, right? 2-pizza team, right? Reorganizing the teams. Go from a 2-pizza team to a 1-pizza team. Because we're developers, we don't like to talk to each other. Make it to where you can sit at the same table to communicate. A key part of that is to make sure you have everyone that you need, so there's no bottlenecks on the database team or the people working on this one application. So we just organized in super small teams that had everyone you needed to do for that feature. And having our code with much lower coupling let us do that. If we also had to address our training problems, right? What we ended up doing is we put some standards in place. And I'm not talking tabs versus spaces standards. Who cares? I'm sure everyone does, but who actually cares as far as going to market? We just needed just enough familiarity so that when you go from component to component, if I work on one product in sprint 1, and then I have to go over here and work on another product, I don't want to have that ramp up time of what is this doing, what's going on. It needs to feel familiar to me as a developer to be able to actually hit the ground running. Your knee-jerk reaction when you're adding a bunch of people is to add a lot of process and a lot of code review. And this isn't saying we didn't have code reviews, right? Like, let's make sure bad code doesn't make it in there. But trust your people to follow standards, right? You hired them, so trust them to do their job. And lastly, training the team on all the components and standards. You don't have so many standards at this point that this is impossible. So just go ahead, and we had some sample code generators that worked, or a lot of different snippets. We had Angular and Java, right? And I'm not a particularly Angular savvy person, or I wasn't at the beginning of this. And so I had an area to go look. And even if, yes, application 3 and 4 didn't look like 1 and 2, I still had somewhere to go. It's easier to copy and paste code and then make it do what you're supposed to do than to just come from scratch. And then last but not least, real documentation, right? Like, not the documentation that makes your management happy. Do it to make your peers happy.
Sorry.
Okay, then we had to address our workload problem. So, you know, we've already annoyed the architects, so let's annoy the Scrum Masters. We changed people around all the time. This isn't mid-sprint, but sprint 1, we might be doing something super data heavy. So, you know, give me a team of all data guys and we're just gonna put our heads down. Next sprint, the work that might actually be needed to do is, you know, CSS work, make the app look pretty. Do you wanna have velocity or do you wanna predict it, right? And I think when you're trying to get to market, having velocity is actually more important. And we also found out that in the end it kind of all washed out because you're still dealing with the same body of people, but you aren't having a database guy just sitting there twiddling their thumbs when we're doing CSS, and vice versa with the front-end guy who's miserable writing SQL.
The Scrum Masters really don't like this.
Yeah, they really
idea,
don't.
Right?
We
So,
can really annoy people with this. Oh well. And then last but not least, addressing our meeting problems. This is actually something that really worked well with us. So we had these super small teams, and then we had one person be the team lead. And that doesn't mean it's the most senior person. You can have an intern as the team lead, right? That's fine. And they're the person who, for that sprint, is in charge of facilitating inter-team communication. Because yes, we've tried to decouple, but sometimes just when you have a bunch of teams working, you're still standing uncomfortably close to each other, or you still might have some merge conflicts, and you're trying to get out fast. We also had a sacrificial lamb, also known as Micah over here, who just dealt with the external meetings and the legacy process. And that really enabled the teams to actually get down and work, because you don't want your new people sitting in a meeting over architecture review board, right? Let them work. Let your database guys work, and just let Micah be miserable by himself, right? Yeah.
All right, so where are we in this story? So we've done quite a bit of refactoring code. We've added some documentation. We've reorganized our teams so that they align appropriately. And we're finally starting to make some progress. So the team's gaining momentum. They're working mostly independently, which is really important. The meeting frequency was reduced greatly for everyone except for me. And our cross-team coordination was minimized as much as possible. And mostly we had appeased the people who loved the legacy process.
Yeah. So, kind of jumping to the end, once we kind of got things restructured, organized so that we could work independently, we really started picking up momentum. We were able to add more people, more 4-person team, 5-person team, 4-person team. We built four applications, over 80 enhancements to the existing applications in just the last 4 months. That's when we wrote this talk. I know it's August now. But, and so this was a really huge success. And in fact, although we had this little period here where we had to do a lot of this, and that put us a little bit behind schedule from the promises that had been made, organizing like this actually has let us catch up and actually get ahead of schedule. So need for speed, right? Just in summary, you have to align the solution in the organization. This is, Conway's law. That means you have to make the system better partitioned so that they're not, cascading changes. Eliminate dependencies and redundancies. Go ahead and repeat yourself, right? That's fine. Once you do that, that will allow you to create standalone teams that don't have a lot of have to have a lot of interaction and coordination with each other. We would say, do some training, the documentation training. Make sure that everyone coming on board understands all the components and they can step in when they are needed in that sprint, and go ahead and move them around, right? If a team is behind, move someone over. I mean, we said we didn't do it mid-sprint, but sometimes we have.
Don't tell the Scrum Masters. We don't tell the Scrum Masters, but that way we can get it done. And then I'd say there are probably many other things that we haven't thought about, and so if any one of y'all has a lot, have ideas that have worked great, we'd love to hear them, right? So, hit us up on Twitter or an email. They're both in the front of the presentation. We'd love to hear from you. So I promised early finish, over delivered. So thank you very much for your time on this Wednesday afternoon, and we'll take any questions. Great, go for it.
So you said you have, like a project owner for the microservices. How many microservices
So
What?
I guess the question here is a project owner, how many microservices does that project owner
own? So the product owners themselves are business owners, like they are the owner of the product. They don't really care from an implementation perspective. They just own like feature and functionality, and then we kind of figure out how to best make that happen with this this application and this set of services. What I think we have to do is, over time, as those applications evolve and we start having a lot of collisions where this product owner's requests and requirements start interfering with this product owner's requests and requirements, and the teams start getting back, that's where we then have to kind of step back, refactor, figure out a way to separate those things so that they don't impact. So it's really not the product owner only cares about, our product owners, our business users only care about the end product.
And if you're asking more from a technical side, we don't have a product owner, but since we've got those standards in place, it really doesn't matter how many microservices. We've got Micah as kind of our overlord and Jason there to back it up. Or if something needs to be refactored, I can just go and kind of do it and then let the team continue working. So since we really do have microservices, it makes it to where you don't have to be like, oh, this is Micah's microservice, or this is Patricia's microservice. We didn't have to do that.
So if
Go ahead.
service A goes down, right, and the team that was working on service A has moved on to B and C, who comes back to work on
That didn't actually happen. We had the first
The question real quick, hold on. The question was, if service A goes down and that team has moved on to be working on service B on the next project, who addresses service A?
Yeah, sorry. So what we actually have is the team that began this project. They continued working on their product. They were adding features for the whole time. So we've been on this for about 2 years, and they're still working on it. So.
Yeah.
And I mean, also the good news about when you get a really large team, that you've got those standards in place, that if service A goes down or if service A suddenly needs a lot of work, you can move people around, right? Oh, we need to give service A some attention, and yeah, maybe it's a late night, but it's a distributed late night, which is always better than being by yourself.
Does that answer the question? Okay, thanks. Any others? Oh, yes.
Are you guys kind of managing shared services and things? I assume there's still some shared functionality between applications and some negotiation there. Is it basically as you determine that you need to break off, you build a new service? What happens to those shared services? How are those supported?
Yeah. So the question is, what about shared services when there are those cases where we find that two things are depending on the same thing and a change has to happen? So, we're not perfectly partitioned, right? I think is the point. So yes, that does happen. Over time, it happens less and less as we continue to evolve and structure it. But when it does happen, we get back to the team leads that do the inter-team coordination. So we recognize, all right, this requirement, going to change that service, and then we can handle that. If it's a non-breaking change or doesn't affect a contract, that's usually not a problem. If it is, we can handle that with versioning, service versioning, or they might just tie releases together if they have to release right about the same time.
We have, in some cases, when things are going really fast, just been like, okay, this is the July 5th release. Commit to this branch. Everything that's going in July 5th goes here.
Yeah.
And, I mean, it's not ideal case, but real world, right?
Yeah. Yes, sir.
How often will you deploy to production?
So the question is, how often do we deploy to production? About monthly.
Sometimes we can go faster. So that's
Yeah,
really
sometimes
not
we were actually
weekly.
Yeah.
And it's not necessarily whether we were ready or not, right? It's based on when the client, that's something that you just have to fit to their
Right.
standards or schedule.
Yeah, if the dependency between these microservices is more, right? When you deploy them, the other team also needs to be.
Yes. That's where those team leads actually really, I can't oversell even if it's an intern, one person who, in addition to their development work, spends a sprint just making sure that you're not wandering off by yourself and that you don't get blindsided by, oh, we're going out now, right?
So, yes, sir.
How can we verify the standards that people from different teams?
I'm sorry, I couldn't hear you.
How can we verify that the standards for coding
Are-
are being followed by other teams?
So the question is, how do we verify that standards are followed by the other teams? And we do that with a code review, just like any other code review. So we didn't, that slide where we talked about we don't have a lot of onerous process, it didn't mean that we don't have code reviews with the team leads like Mike and Patricia. What it means is we didn't have we march in every Thursday at 2 o'clock to the Enterprise Architecture Committee, who's had to do that, right, and present it. And if they didn't like it, we could come back next Thursday, right? So we didn't have that type of process, but we did have internal code review process really at check-in time, right? So
And also, if you think about it, you're not at least in our case, we weren't continually adding people every day, right? You get people in kind of waves. And so there might be a wave where I might not do that much development that sprint. I might just kind of sit with people and make sure they get going. But I mean, again, you hired the people, they're competent. Once you teach them what to do, and once they have all these, really giving them all the code examples and having these code snippets actually made our code review process, or I saw a big difference in the quality of stuff, right, before and after, because they're making it look like something that looks good. So it was really having the standards, and then if you get a big wave of people, and yeah, maybe I'm not going to get to put my headphones in that much for a couple of weeks, but at the end of the day, it wasn't that much of a problem, actually.
I think that, to be honest too, is that functioning code that's well tested is kind of passes. We can always refactor it, so.
Yeah. Yeah.
You mentioned testing. What's the scope of your testing as you push out a new service?
Yeah.
You test everything,
So-
or just
Yeah, the question is, what's the scope of testing when we push on a new service, Micah?
Yeah, so we have unit tests for everything that gets built. Every new service that we endpoint that comes on, we build unit tests for it, and we build an integration test for that as well. We've also added quite a few consumer tests. Now, we didn't start with that, but those have been added, especially for anything that's shared. We've got a consumer test for it. So we're adding those slowly. We probably have, I don't know, 100 or so.
And also, like, in this particular case, right, we just chose one case example, but in our one case example, the client has their own QA team that wants to verify, right, because that makes sense. So, I mean, stuff is getting tested, and if I feel like, oh, this is kind of, what I'm working on is kind of scary, I'm going to get my buddies to come over and make sure that what I'm doing makes sense as well.
if I can follow up, you mentioned client testing. Did you get pushback on your release cycle from your client in terms of them not being able to test on that?
So the question was, did we get pushback from the client on not being and on them not being able to keep up and test fast enough? Absolutely, yes. And they're giving me the 1 minute sign back here, so we'll wrap up. But I think those are some of the external legacy dependencies that we do struggle with, and we'd love to hear from you guys on strategies for that. But we if you want to come up, everyone's come up afterwards, we can continue talking. So thanks again for your time. We appreciate everyone's attendance, and I hope you have a good rest of the conference.